In this video, I'm going to talk about the difference between fine-tuning all the way to prompt engineering. We talk about the different techniques that also come in between and where is the best to use which approaches and what are different stages of your company from a startup to a large-scale company need to deploy when they want to use the capability of generative AI. So without further ado, let's jump right into it. Welcome everyone to your channel, AI Fun Fact for All. For those of you who are new to this channel, my name is Pedro Magan. I have a PhD in computer science, and in this channel, we talk about AI and machine learning and how we can use it in our everyday life. In this video, as I mentioned, I'm going over prompt engineering all the way to fine-tuning and how we can use this generative AI capability to make it more adaptable and suitable for our specific use cases. There's a nice white paper from VanDB that actually discussed this topic in detail that we will go over in this video, and I will share my thoughts on what I think is a better way to go over them, and if some of the topics I totally agree, we will definitely reiterate on that. And if you want to download that PDF, make sure to look at the description of the video and you can basically download the PDF for yourself. Make sure to watch until the end of the video as I will talk about more advanced prompt engineering, as in automated prompting such as prompt mining, that try to tackle this problem of engineering is a more automated way. So because there are so many people are thinking right now that the prompt engineering technique is going to be isolated in a few months from now, and a lot of this language model will try to do this process automatically, which I agree to some extent, but it doesn't violate the fact that you still need to know what a language model would need in order to provide you a good response, because as a good engineer you need to know the fundamental. Same as right now, lots of people who still work and try to focus on some conventional linear systems, well, they are not actually applicable in the real world, but they still give them some insight from the fundamentals that they can use in order to come up with more advanced and nuanced responses. Now let's start from the difference between fine-tuning and prompting and where to use when. So as you can see in here, we have the large language model that are developed for general purposes. So if we want to use it for our specific task, we need to do some kind of adaptation that make it more specific for our use case. And based on the different use cases that we have, if it is very much like advanced and the basically pre-trained data that are basically the internet, our data is very unique and it's never seen that. So it is our method will definitely require more of fine-tuning in order to be applicable for a specific domain. So there are different prompts and popular fine-tuning methods that we will discuss in more detail in this basically white paper. So we have talked about fully fine-tuning. So this is the first one, which you try to update all of the parameters of the model. Obviously, it is very hard to train like a very large model. You require a lot of resources and obviously a lot of data. You can use an idea of transfer learning, which you basically change the layer of your pre-trained model and adapt it to the new task, or you can use knowledge distillation, which you use a larger model and try to make it smaller so you can increase your inference line. Then we have parameter efficient fine-tuning. This is an approach that is used to update a small fraction of the original model parameters, or something around like 2%. And there are different methods. We have adaptive tuning and also something like LoRA, so low rank matrix adaptation. It will try to approximate the larger model and try to basically update the original model. And then we have Prefix-Tuning, which basically prepends some task-specific vector and try to tune the hyperparameters of those things. So obviously we are not going into too much detail. In here, we'll just give you a rough idea of what are the breadth of the topic, and then you can definitely get deep into which approach you want to use. And then we have instruction tuning, which is actually the breakthrough in natural language processing in 2022, and actually provide the results that are more aligned with what a human would look like, and then it will try to provide and use as a general purpose language model. So when you look at the model repository, you will see some original pre-trained, and then you have instruct fine-tuning version. Which basically, by the way, very useful, and most of the time people use the instruction tuning one. And then we have more refinement after that, which comes with either RLHF, reinforcement learning with human feedback, or a more lightweight and non-RL based approaches which directly optimize the preference with DPO. These are two of the common techniques. I would say majority of the time DPO is deployed because of the simplicity. Since the LLM is actually trying to predict the next token, you are trying to somehow give it the context that the LLM should try to provide the response to. Rather than being very generic, you want it to ignite some specific parts of the model, and since it is a next token generation, if you provide some specific keywords, it will try to provide you with some good response. So I would say prompting is actually very important, even though right now people are talking about, oh, we don't necessarily need to know. There are so many different approaches that we will cover them in this video. And then we have a prompt optimization, we have prompt engineering, which is basically you have some templates, and these templates are different for different models. Some models requires different models. For example, the one that you use for Meta is probably different from the one that you use, for example, for OpenAI, and so on. And then we have prompt tuning, which you basically don't try to use something, some actual token or something from natural language processing. You try to use some soft prompting or somewhat not actual prompt to append to your basic input text and try to generate some responses that is more aligned with what you are looking for. If there is objective true answer to the question that you're looking for example, the classification task or a transition. So for this, a fine-tuning on a smaller model generally works better than prompting. So if you are doing a simple like just classification, definitely try to go with fine-tuning on a smaller model. You don't necessarily need a large model for that. And then if you want to have some generative tasks, such as, for example, result output, copywriting, code completion, and so on, now for this one, you better have to do prompting. However, if it is very specific for your task, something that you want, probably something that doesn't seem, so it's basically a hard problem. So you need to come up with some fine-tuning. And then this idea is also very nice, generalization versus specialization. So the fact that we want to make this model work better for our case, basically moving the model from general to some specific task. So then you have a model that is not going to be well responsive in other tasks. So and that's a very common, well-known problem as catastrophic forgetting. So you need to be aware that if you have your model and want to specialize in one specific task, then it's not going to be well in other tasks. And that's the idea of why do we have different agents and how we can have different prompts of different tasks, and how we can use some approaches such as LangChain and so on to basically find different routes of the specific task we have. We will get to that shortly, but I've also have created a video on how to use, for example, this kind of LangChain and so on, or agentic AI, and how we can generate them for a specific like a llama stack. I will put the link of that in the end of this video. And then we have scalability and simplicity. So different dependent on what your current stage of the company is. If you have a larger scale, you probably want to go with fine tuning, but if it is a small, maybe you start from the basically very small version. I will get back to that. Like you start from the API, and then gradually you try to get more advanced methods like prompt engineering, and then after that fine tuning. And then task-specific sample size. So if your sample size is not enough, if you don't have enough data, probably you can't go with the basically fine-tuning. And then memory and what is the cost of your inference. And a more pragmatic approach involves breaking tasks into components and prototyping and evaluating. So this is actually the one that I already talked about, which is basically using the agentic, and I believe this is the most efficient way to solve lots of problems. You have different agents, kind of also inspired from the mix of expert. You have different experts that are working and specific for one specific task, and the fact is that you need to router to know which one you need to have at the current moment. So this is the task. Like for the startup, you start from a commercialized API, and then you go to collecting your data and try to do prompting, and then after that you will try to do additional changes, such as, for example, replacing with your like you try to self-host it, you try to self-train, and so on. And here you can see the difference between task specialization and generalizability. So these are working against each other, and in a pre-training approach, you have a very general version model that works on wide variety, but probably not going to work very well on your specific problem. So you can use prompt pre-training, you can use instruction tuning. So for instruction tuning, I would say it still would be considered generalized approach. The feature-based approaches is that you want to use the most important capability of a language model, which is basically the embedding. So you want to use the embedding, which is like the perception of what are the information contained within the context of the window, and then try to use another completely different approach in order to come up with your downstream task response. For example, you can use XGBoost, random forest regression, and so on. So you just try to extract some feature using this embedding, and then try to use other things at the end to basically provide you with the downstream task. And usually the one that we use for embedding is basically BERT model. So you can also use GPT style, but I would say embedding focused models are more BERT. And then after that, we have updating only the output layer. So the output layer is that all of the model in the beginning, which do all of the feature engineering and so on, are kept fixed, but only the output layer, which basically on a problem of a classification, which can be just a softmax, or in a problem of, for example, next token generation, it can be like, for example, other output layer based on what our downstream task is, and then we just change the very end bottleneck, which would be more considered in a transfer learning paradigm. And then at the end we update all of the layers. So all of the layers you can certainly do, but I would say it comes with its own problem. For a larger model, it's kind of require a lot of different data, but you can do also, like with the BERTs, around 110 million parameters you can use, but then we can again also use some small portion of that model to obtain. The advantage is that you can achieve the highest accuracy. So obviously, if you do full fine-tuning, you basically give the highest accuracy. Definitely you can't do better than full fine-tuning, but the disadvantages are a lot. Like, for example, you will have a model that is only for a single task, not going to work well with other tasks. You can do fine-tune models that might overfit to your task, so all of the problems that we have with overfitting can also appears to be here. And then in context learning and prompt-based approaches, they have like the problem of out of distribution generalization, so the generalization will be obviously limited. And then we have parameter efficient fine-tuning, which you try to use just a small portion of the model. And how you can do that is basically you can use one of the famous models like LoRA, which try to say that, okay, we can have a smaller size of the model and just try to update that a smaller size of K and V instead of the whole parameter, which is around like maybe 2% of the whole number of parameters. And then we have adaptive tuning, which basically inserts additional task-specific layer to the pre-trained model, which LoRA would be considered as one of them. And then they have prefix-tuning. So prefix-tuning, as you can see in here, is you add some prefix in the very beginning of your whole model, of your whole input, and then this one are not necessarily basically a specific token. They are basically some vector and they are continuous, and you add them and then you try to update those vectors to see which of them would provide the best response for you. So we talked about the advantage and disadvantage of fine-tuning, and then we have prompt tuning, which is very similar to prefix, but the idea is that instead of having vector, we try to impose some soft prompt. But again, soft prompt are not actual tokens. They are basically some of the different set of like prefix that you kind of add in the beginning, and then it will improve the performance, and you use some gradient based method in order to come up with them. And then we have instruction tuning, which we talked about it, which you try to give a set of question and a desired output, and then ask the model to actually follow that. Otherwise, a general purpose LLM is just try to generate the next token rather than following a task. And then we have RLHF. So RLHF, I'm not gonna go very deep into it, but the whole idea would be to have basically like for example, an RL approach like a PPO, and then try to use this policy in order to align and try to generate a reward function, and then based on the output, you try to give it some reward, and then after a while, you try to align it, which try to maximize the reward. Let me know in the comment if you want me to go deeper into RLHF, and then I can basically provide a video on that one as well. But then I would say necessarily you don't necessarily need to apply RLHF. DPO would usually be the response unless it's a very special case. And then we have the prompting. So for prompting, it is very important that you make sure that you understand that prompting is some techniques that you're using that is different from a model to another model. So you have to have a specialized structure for each model, and then also it is not guaranteed. So on different runs it can generate different responses, so you need to look at on average what is going to work well, but the whole idea is that basically also model parameters is freeze. But then if you want the LLM to generate some word like Bonaparte, what you do, you try to append some common collocation. For example, Napoleon. So it try to, as it's like generated next token, it try to give you a much higher probability. I have talked about this prompt, this idea about prompting in my previous video, and said that if you provide some special keywords in your prompt, that will ignite a specific part. That's basically this idea. When you want to provide you a response that is specific for a task, try to come up with some of the words that are special in that context, rather than something very simple of the words. And that will try to provide you a more generic response. So that's why I said it's really important that you know the technique of prompting. And then we have manual prompt versus automated prompt. So this is the part that I mentioned in the beginning of the video, which are right that people are going towards the automated prompt design. We have seen lots of different prompting like chain of thoughts and so on, so that it gain a lot of interest. But then we have seen like all three or one model, these are deploying like this chain of thought under the hood. So these are the fact that how we can actually automate this process. These are more advanced prompt engineering techniques. So for automated prompt design, I can say we have prompt mining. So prompt mining, you have a large text corpus, and then you try to find some middle words or dependency paths between the input and output, and try to find which of them actually works better. Or prompt paraphrasing, you take an existing pre-seed of the prompt, and then you try to paraphrase it into different and see which one actually provide you the highest training accuracy. And then we have gradient based, which basically you try to have a short token and try to change the sequence such that it trigger the underlying pre-trained LLM to desire the target prediction. So these are more advanced or automated prompt design that are right now you see a lot in the everyday. Then we have advantage of prompting. So I think we already have talked about it. Like for example, the few shot prompting reduced it to a major reduction in task-specific data, and then it's applicable to zero-shot setting, and then it doesn't require any update of the parameter. We obviously don't have any catastrophic forgetting, and then it generates human interpretable prompt templates. So these are very important because then you don't necessarily need a special person to actually come up with the result. You can use and make it applicable and usable for lots of people, like for example SMEs or the other people. They can actually look at this best template and try to deploy it themselves. But at the same time, it comes with some of the disadvantage, which basically it is limited, so it cannot go above and beyond. There is a limit that you get, and obviously in some of the specific cases it won't provide a good response, and it's also very dependent on the scale of the model. So if your model is a small, probably in context learning or prompt engineering wouldn't work well. These are the ones that work with the larger model. You get the response that can vary a lot, and then you need to run them multiple times to see which one actually works better, and it requires some manual work for different problems. So I've already talked about chain of thought, so I'm going to over that in this part. Then we have a prompt chaining, which I think is an important topic. The prompt chaining is the idea that you try to decompose your prompt, or you have a very big general task. You try to decompose into different sequence or parallel of tasks, and then you try to have a DAG or directed graph and know that which one should go where, and you have some specific basic LLMs, or we can call it agents, that are specific for that task, and they try to do those specific tasks and then go to the next one. And this prompt basically chaining is the more of the approach that people are considering in the 2025 and the whole area of agentic AI, which I've also talked about the idea of LangChain, and also how we can use it in basically a structure that you can use a RAG or retrieval augmented generation in order to provide related information to the LLM and have different components that is capable of doing some specific tasks. And there you have it, guys. We went over different approaches from prompt engineering all the way to full fine-tuning and discuss on the high level what are the different breadth of the different approaches and what I think would be the path to go and what we need to know about these approaches. If you enjoyed this video, make sure to like it, and more importantly, subscribe to the channel so you see upcoming video about the more advanced topic in this area. If you want to see more videos like this about the agents and the future of AI, make sure to watch this video that I created about the NVIDIA CEO talk about the future of AI agents in 2025. And also, if you want to have more hands-on experience, you can actually watch this video that I talk about how we can use the basically llama stack in order to provide an agentic pipeline in the prompt chaining technique, and you can have a specific basically agents that are specific for different tasks, and then we can actually look at how they are connected to each other. Thanks for watching and see you until the next one.